So, hello everyone. Thanks for the opportunity to speak to you about acrionlua, which is a C++ extension to Lua. And although this is done in context of a company, this extension is freeware, and it will be on GitHub, will be published on GitHub. First, let me introduce myself and the company, and then go into details. So we are two and doing software development for other companies, mainly C++ software development for embedded systems where Lua naturally can play a role. Let me show you two examples of what this can be. For example, measurements on electrical vector network analyzers, where you have high-frequency signals and want to post-process them. So these signals can be up to 1 terahertz. And usually you don't display them, you can display them, but usually you take other actions, like for example on a cell phone production line, you have to be very sure that a cell phone doesn't send any nonsense in the net. Here Lua can play a role, or plays a role to arrange a lot of network analyzers so they can make a useful system together. On second example, so I worked for a lot of companies in Germany and Switzerland. The second example could be surgical devices, where you use computer vision. For example, if you have a surgery on the human retina, you want to overlay the image which the surgeon sees with pre-captured images of blood vessels, and you have to track the retina in real time and then overlay this information where the blood vessels are during the surgery. So this is stuff that I've done, and as I explained, Lua plays a role in embedded systems, of course, but we not only do software development for other countries, we also have own products. So let me show you 3 examples. So Aristarch is a chess engine which now plays no role anymore, but it was one of the first who was able to, well, it was rather strong. It was a rather strong freeware chess engine that I developed. And a second thing is it's really in nowadays still interesting, because a client of myself recently evaluated that JetPix, which is an image compression technology, is still better regarding performance and image quality than JPEG 2000. And Straton, which leads to the topic, the product which is this talk is about, is an image segmentation software used by astrophotographers. So you can buy it and do some step in the process of post-processing astronomy photos that was missing, and it's filled with this software. And yeah, so let's continue with this product. So this is the product Straton, which I'm showing here. It has a rather simple software design. It's specialized on Windows and uses some .NET assembly, which does image processing. But now we want to do something different. It's also about image processing, but it does more than this. So we have to have a better design. So first thing is it should be multi-platform. And just to avoid confusion. So no Lua up to now. Yeah? So Lua plays a role later in this design. I will show you now the idea of using Lua and then the idea of extending it. And this is the first part of my presentation where I show you the motivation, why we did this. And the second part, I show the details. So this leads to why we did this. So first thing, this user interface should be multi-platform, and it should support multiple plugins, shared libraries where we implement this image processing. So we need a different design. So if this product would have been developed by some of my clients, maybe this would be the end of the software design, because, well, the core functionality is here, everything is here, we don't need anything more. But as it's the own product, I had the freedom to do more regarding software design and make it much more flexible than this. So first thing is, do some refactoring, move the image I/O, which was previously in the user interface, into a plugin. So the user interface is really free of the image processing functionality, the image I/O. Move it into a third plugin. Now we have 3 plugins. This is naturally a free plugin, which just does image I/O, and the other 2 are commercial. And so this sounds like, a product manager could ask, why do we this? What's the benefit? What's the requirement? There's no need for this. So why put this in a plugin? But when doing this, it suddenly turns out we have additional possibilities. We can introduce a second user interface, a command line interface. The customers are not used to use batch processing, but I can imagine very well that they will want to use it. So if we would do market analysis, probably no customer would say we need this, but I can imagine they need it. So we have innovation in our name. So if the customers, maybe they would have the idea if there were other products doing that. But when we have the first one, this is innovation, so we do something without asking the customers and try to make them enthusiastic about it. So I'm talking now a lot of this plugin stuff. Although the plugin stuff is not really the main part of my presentation, but it leads to us to these extensions of Lua. So, of course, we need some GitHub repo where we store the metadata of the plugins, so we can have a list of them and have URLs where they are available. Then we want to introduce scripting because it makes it much more flexible. We can use these image processing shared libraries in different ways. We can even do some minor algorithms in Lua. So now there's a problem. Because if we introduce scripting here, we have to load these shared libraries in an efficient way and make use of the functionality. So which scripting language is suited to this? Well, Lua is perfectly suited to this, but we need some way to flexibly load shared libraries. And the problem is that this plugin interface will be open. So everyone can develop plugins for this platform. What is that idea of promoting this? We have our own plugins, partly commercial, partly freeware, but anyone can do this. So it's an open interface, and if someone wants to load some functionality using OpenCV or whatever, and there is this Lua interface, which we want him to use, then we need to provide some way to flexibly import shared libraries. So this is not in the form available that we need, not in this flexible form that we need. And there's a second thing which we need. Well, this is just some minor addition. We make these shared libraries even optional because there might be some users that really want to do image processing just using Lua, which would be very unconventional. But well, it's simple to introduce some functions to do this because we need some functions to modify memory address, to write into memory, read from memory, so we register some functions that do this, which would seem to be dangerous because you can crash the whole application if you do this, but essentially we do nothing else than if the user would provide a C++ plugin where you can do the same. Yeah? So it's just moving functionality from C++ to be available in Lua. So now a second thing. So this is one thing, loading shared libraries. But a second thing is the problem that if you provide a plugin interface, naturally the plugin can crash the UI. But that's not even the main problem that it crashes the UI. The main problem is that it isn't responsive anymore. So you could, of course, implement this in the UI, so in the command line interface and the UI. So you call these plugins asynchronously. But no, I thought, well, why not also put this in this acrionlua static library, which is nothing else, technically speaking, of all the C code of Lua plus C++ code that extends it. So the Lua code is not changed in any way. It's just C++ extended. So why not put this into this library to avoid such a really bad thing like you see on the left side. We don't want to see this. The UI should be always perfectly responsive. So we need real multithreading to do this because you have coroutines. You cannot avoid that the thread which you are working is has 100% CPU load. So you have to do real multi-threading. And the idea is to extend Lua to send messages asynchronously and receive messages asynchronously, which will call functions essentially. So let's come to the first part. Oh, well, I just added here some Jenkins overview. There are a lot of jobs which build all this. This is just for overview of you. So the left side is freeware, the right side is completely freeware, including the user interfaces. And this middle part is the commercial one, closed source. So again, something about the plugin, very short, just to show you how flexible it is. So the plugin in Lua can describe itself, it can describe its parameters, parameter types, and also an icon, a short description. And this can be translated by UI into just things. So this is really completely generic. So the UI displays then the parameters, you can choose and configure them. Yeah. So let's go into details. So this is a new Lua function import. And I would like to give you a short insight on how this is implemented. So this is really C++ focused. But here on the left side, you see Lua code. So it's rather simple to call a function from on Windows DLL, or on Mac OS it's a dilib, and on Linux it's a SO. It's completely multi-platform, and this is also tested, of course. So all these plugins are multi-platform plugins. So what you do is you write import. And on Windows, for example, there would be some DLL Acrion image tools DLL, which really exists. This is a freeware plugin providing also image I/O stuff, and also primitive image processing functions like subtracting two images from one another. So this is named subtract working image from reference because in the UI, the concept of the UI, which is the reason why there is even a new UI for this, because it's a new innovative concept with two images where you can do arithmetic and stuff. So then this function is one of the arithmetic functions. And what is done here, it's loaded, which is, for example, load library on Windows. And on the right side, which is a little bit cut off here, you see the signature of this function. Which is a C signature, so I have the return types and a bracket, a list of parameter types, and a closing bracket. So this is loaded, and we don't reinvent the wheel. So loading DLLs in a multi-platform way brings all kinds of complications. And luckily, there is Boost DLL, which we get rid of all these problems, like the function decorations or whatever. So it simply works. It's a one-liner in BoostDLL. It's simply also one line in BoostDLL to load this shared library. The tricky part is to how to call it. So the import function also stores the signature of this function in a map. So as soon as we have the function name, we can look up the signature. And the next thing is we have to tell Lua about this new function. So we register a new function. And an interesting thing is that all of these new functions point to the very same C++ function or C function. It's actually a C++ function, but it's not in a class, so it can be registered that way with Lua push C function, Lua set global. Every time someone calls this function subtract working image from reference inside Lua will call this function call DLL function. Yeah? So this is the first part. So, but then now we actually want to, let me just go back, want to do the second line. We want to execute the function. So when we are there, the function is executed, we know nothing. We know nothing. We are just always in the same function, call the DLL function. So we need to retrieve the function name of the calling Lua function. There's luckily a function that provides us with this information, Lua get info. There are some other interesting things that Lua get info can be used for, but I had some problems with it. This would be just for error checking. But with this just as a side note, but the important thing which we need is reliable. So this is the name of the calling function. So then we have this pre-stored map, which was allocated when we call import. So we find the signature of the function. Yeah, and now we want to call this function. So there are two ways to do this. And I'm first showing the primitive way, which is a fallback solution. And there's some drawback of this whole design, I have to admit, because if you load libraries in that way via C++, you cannot load them via strings, completely flexible. You have to hard code the signature in the object file. So this is an unconventional approach, but the slow method of doing this is just an endless chain of if clauses that searches for the signature and then uses BoostDLL to call the function. And you see this is generated code here on the right side. It's nearly 3,500 lines. This is configurable, so you can extend it or do whatever it is. But I will come to this restriction later. Yeah? So, but now we also have a way better method of doing this. You don't need to actually go through an endless chain of if clauses. There's a way better way, so you can do it instantly. This is a more complicated way. So you pre-allocate a map in C++, which can use the signature of the function as a key, and the value of this map of an entry is a function pointer, or rather a standard function. And you see this pre-allocation here, that thing. So this is one line of the generated code. I just extracted it to be more readable, but this is essentially one line which does this. So it the function which is put into this map is a function that accepts an instance of a DLL, which we loaded, accepts the function name and the Lua state. And now we can, just as on the right side, where we do the search during the calling the function, we fill this map of function pointers with this function call. So this is not done at runtime, it's pre-allocated. And if you call it, using the hash, you know all the hash method of maps. It's instantly found, and then it can be instantly called, and there's no delay. But as I explained, both sides have a restriction that everything needs to be in the object file. And in fact, the true restriction comes from the C++ compiler. So interestingly, the C++ compiler has needs a lot of time of compiling this. No, it's not so surprising, but it needs a lot of time. So I think it needs on a standard laptop just 1 minute to compile these 600 lines here. If you further extend it, it can come down to 10 minutes or whatever. It needs a lot of time. And the write side is restricted not by the compilation time, but by the size of the object size. So at some point, the compiler refuses to work. So, so this is unconditional approach, but it's very flexible, which I explain here on the next slide. We have a maximum number of arguments of 15. So 15 arguments is a lot for a Lua function. So, and you have to keep in mind that this whole thing is not to load primarily arbitrary DLLs from OpenCV or so. The whole thing is because we have plugin developers on mind, unknown plugin developers who want to provide their own C++ shared libraries, and we want to use them. So they are perfectly able of using a function signature that is available here. But even if they want to call other functions, this concept is so flexible that they have a good chance that we support this signature. The second restriction is, of course, the parameter types. So we only support the Lua parameter types. So string, bool, double, an integer or long, and a light user data or void asterisk. So this is also restricted to. So let me just add one thing. This is a code generator. The code generator is written in Lua. It generates a C++ code that then is compiled. So this code generator can, of course, be adapted. So if you need some function, you can simply add it to the code generator, and this whole thing works. So this is the first thing, this new import function and calling functions. And I explained it's multi-platform. Yeah. So the second new thing is this multi-threading. So multi-threading is complicated and it uses lots of problems. So I wouldn't have even tried this if not accidentally I also developed a solution for C++, because even in C++ you have the situation that you can, if you use the standard library in the wrong ways, you easily run into a situation that you have some deadlocks or whatever. So I wrote a library, an open source library for C++ that works around these issues. So it's essentially just sending messages, receiving messages, and caring about startup and shutdown. So all these complicated issues are wrapped up. It's a single header file which is full of templates and completely unreadable, but it's well documented here, so you can use it to make a simple concurrent design in C++. And that's what I transferred to Lua. So if that wouldn't be available accidentally, I made this, in effect, for a product for a customer, but I didn't. I did this not in the scope of the project, but it was a motivation to do this. So I used it in the product which I did for the customer to make a better software design there, to be able to really have several modules. One addresses the hardware, one is the UI, and nothing blocks the other part. And I think, just as a side note, this design is, I think I wrote it here somewhere. I wrote it here. I think the reason for using single threading lies solely in the design of the programming languages. I mean, this is an important point. So why do we use usually single threading? Because you have run into problems with multi-threading. But imagine you wouldn't have this situation. Why? Multi-threading could even be the default. Yeah, you have one function calling the other. Why not send it a message like it's in Erlang? So this was the motivation of doing this, implementing this C++ library. So what do we have to do to make this available in Lua? We have to care about the Lua state. I don't get into details here. So this is not trivial. We have to do some mutexes and stuff. I cannot get here into detail. I just want to tell you what's done and what is needed to implement in Lua. The second thing is we have to register a function to send a message. And so this CLime library, I forgot to spell the name, so it's an acronym, C++ Light Messaging Library. If you want to use this, then you have to decide about the type that you want to send via a message, some data type. It could be an int, or it could be even an image, because it's not copied, which is an important point. So this message is never copied. And it also cares about lifetime of this message. You don't have to care about this. So what message type do we use in Lua? So currently, I did it that way. So this is open to discussion because it's not published yet. I will publish it on GitHub, open source. But there may be points which should be improved. But this is sufficient for our commercial product. But maybe something can be improved here. What is sent here is a nested table structure. So in Lua, everything is tables, so you're able to send anything. So the message type, this one here, message to Lua, is just one string and a nested Lua table, which contains other tables. And this is always sent, so it's restricted to that, but it's not really a restriction, as I explained. So there's message to Lua, message from Lua. So in C++, the coding is really finished. So there's also macro, is use in C++ sends something to Lua asynchronously. So this is sending. And then we need the receiving part, a function to handle a message. So this is C++ code doing this. It uses the CLime library to do this. So you have a message handler. Then you have a handler in case of exceptions. Then you have a handler in case you have idle. If you don't have this handler, then no processing time is used. If you put this handler here, you have to take care that what is done when we have the idle situation. So this is the current state. And now the next step is, of course, to register Lua functions to as I did with the load library, with the import function. You just have to register a Lua function that sends messages. I would say this is 90% finished, this thing. Of course, I'm open to suggestions on how to design the Lua layer. I would be very interested in collaborations. I will, as I explained, also publish it on GitHub. So my very simple idea would be just register a Lua function to send messages. The receiving part is more tricky. You have to think about Lua chunks. But essentially, when receiving a message, a Lua function would be called. But then, of course, you have to take care about the state. What's the state? And in what context is this handler called? And so this is not yet implemented. Yeah, but I can even publish it in the current state on GitHub. There's also documentation, Doxygen documentation. Yeah, so this is a short overview. So I'm near to the end of my presentation. What's available, because I told a lot, so I made it this to give you a short overview. So we have a library, acrionlua. As I explained, it contains a C code of Lua plus C++ code. And there's the new Lua functions import and send message. And then when receiving messages, I explained the name of the functions are configurable because it's the message name. Okay, and what does it use? It uses Lua. It uses the CLime message passing library to do this multi-threading stuff, and it uses a Boost library to do the shared library loading. And in addition, it has connection to a server, which is placed on GitHub, where the metadata of all plugins, including the commercial ones, are available. Yeah, I think this should be the end of my presentation, yes. So I think we planned some question round. So I hope it was not too much in the presentation. So if you have any questions, I'm available now.
What was the hardest part to implement from everything that you showed us?
The hardest part, well, if you take into account this C-Lime light measuring parsing library, the effort of developing this, then it was for sure the multi-threading part, and it will cause additional effort now because it's not so straightforward to care about those Lua states, and it's not finished. So I would say the idea regarding the shared library usage is rather clear. Yeah? The only question is really do it? Because we are, as explained, we are restricted to certain signatures, but as it's not really a restriction, as I explained, I just did it. Was kind of fun also, but this, I think the multi-threading part is more tricky. Thanks.
You know, for your calling the external DLLs, right?
Mm-hmm.
Why didn't you think of using LuaJIT's FFI?
Because we want to have something that we can easily compile into the user interface, and honestly, I'm also not so experienced with LuaJIT, so this is a simple explanation. So we wanted to have something lightweight that we can compile easily into an existing user interface. I'm open to discussion for this point.
Yeah, because if are you calling C++ functions or C functions?
C++.
Okay.
The C++, yeah, for sure C++, because all this computer vision stuff is...
So how do you handle complex objects like structures or classes?
Handle in what regard?
From Lua to C++.
Well, you're really restricted to those data types. So there's no way doing this.
Primitive types. Okay.
Yeah, of course, let me just add one point which comes to my mind. Of course, it would be an option to use a REST interface, to completely isolate it using processes. But then we have the drawback that we need serialization, and it's also, of course, a performance problem. Yeah? So we don't want to copy those options. We don't want to send them over net, although it's very fast. But we don't want to copy. We don't want to serialize. So that's why process isolation was not an option.
So the C++ standard doesn't guarantee any API compatibilities, right? How do you handle different name mangling, different compiler options, etc.?
I have a very easy answer for this. This is completely done by Boost, by the Boost library. So this is a part, or this is a task we put there, and the Boost library is very reliable. So maybe you know that gradually lots of parts of the Boost library are transferred to the STL. For example, the file system library was originally Boost library, now it's STL. And this shared library stuff is not yet in the STL. I don't know if there are any plans to do it, but generally this Boost library is really one of the, even the most reliable C++ library. And I cannot answer technically your question. I just say that this is the best way of handling with the problem. Yeah, it's multi-platform Boost library, and it handles all with this function declaration stuff, and yeah, so this is my answer.
All right, because as far as I know, the only sane thing to do is you make sure you use exactly the same compiler version, the same command line flags you use to compile, to make sure if you're calling C++ functions, to not get into trouble.
Let me think. I don't know. Now I know what you're referring to. No, this is a misunderstanding. What you actually do is we don't call functions from classes. We actually call C functions.
Okay.
So this is the true answer. Yeah, this was a misunderstanding. So we use this boost library to actually call C functions. But the thing is that the signature in DLL of C functions is a one part, but you can actually put C++ code inside the function. Yeah.
Right, so you
That's-
use C functions
yes.
to wrap the C++ implementation,
Yes.
and use the C ABI, which can do these, which has these additional guarantees.
Yeah, sorry, it didn't came to my mind at first, but yeah, that's the true answer.
Thank you.
Okay. So,
I know from the Lua in gaming that if somebody decides to include Lua, it's a frozen Lua. So the games are with Luas 5.1 and 5.3. They will never upgrade. So what is your roadmap? Will you include further Lua versions, or as you modified something, it's not the same, you will stay with this one version?
no, a good question. So, I have lots of experience with merging questions and whatever, so I can simply promise that this is exchangeable. So the Lua part isn't touched, and you can exchange it. And of course, if there is need for it, I would be happy to provide some way to make it easier to exchange the Lua version. Technically speaking, in the GitHub repository, the Lua code is a submodule. So hopefully it simply works if I exchange the version of the submodule. Yeah. I don't know. I didn't try.
Maybe you can continue.
Okay, so thank you for your questions and your time.